All right, I apologize. I'm just using the low tech today instead of my fancy screencasts. But just to finish up, because I want you to have the full examples. So for example 1, determine whether or not the graph is that of a function by using the vertical line test. So that's the first thing. Any vertical line that I would draw here is not going to touch more than once. So that means that this passes the vertical line test, and it is indeed a function. Second thing it asks, find the domain and range. So domain are my inputs, my x values in this case. So domain and range in interval notation are always listed from lowest value to highest value. So lowest value on domain is going to be the leftmost point. So as I move to the left, this is the lowest point I can reach. So the x at that value is 0. It's a closed circle, which means I include the value. So from 0 to the highest value, I look to the right. So as I come in from this side, I'm going to the right. I have to stop right at this point. And that x value there is 4. It is an open circle, so that means I do not include that particular value. So it stays with a parenthesis. The range, same idea, except with domain, I look to the left, then I look to the right. With range, I look down first, so lowest possible value is at this point. The y value there is 0. After I look down for the lowest value, then I look up for the highest value, and the highest value I can reach is at this point. Again, range is the y's, so the 3. Again, it gets a parenthesis because that's an open circle there. When I look at this for intercepts, x-axis, it touches right there at that filled in point. So the origin, 0, 0, is both simultaneously an x and a y-intercept. And I don't have any others. It doesn't cross the x-axis any other times, nor the y-axis. X-axis, y-axis, or origin symmetry, this has none of those. If I fold on the x-axis, I would need something down here for it to have symmetry, and I don't. Y-axis, I would need something over here. It's not there. If I turn this upside down, it does not look like the same picture. So we now know that it doesn't have any of those types. So none of x-axis, y-axis, nor origin symmetry. So now I'm going to continue the part of example 2 that I didn't get to finish. So I know I was talking a little fast at the end, so I'm just going to go over what these last two mean again. So if x is 0, that is what tells me to plug in 0 for x. So that's what I did over here. It says, what is f of x? Remember that saying what is f of x is the same as saying what is y. This is like saying y equals. So I answered that question. When I plug in 0, I get 1/2. What is the point on the graph? Point means ordered pair. So x was 0, y was 1/2. That's how I got this guy here. Down here, read carefully because I get kids a lot who will just see that they gave you a value and automatically plug it in for x. In this case, we're plugging in for y. So I put the 1/2 in place of the y. Again, this is a rational function. So I can't simplify over here. Don't try to tell me, and don't write this down because I'm going to erase it. This is wrong. You can't say x squared over x is x, 2 over 4 is 1/2, so it's this. Absolutely not. So in Algebra 1, when I teach this, I call this hacking. I don't know what your Algebra 1 and Algebra 2 teachers taught you or called it, but these are attached to each other by addition. You can only reduce things if they're separated by multiplication. So that is a huge no-no. You have to solve by cross multiplying. So 1 times x plus 4 is how I got the left side. 2 times x squared plus 2, which needs distributed, gives me 2x plus 4 on the right side. From there, I'm just solving this equation. So it's quadratic, which means I'm going to get it equal to 0. So minus x minus 4 on both sides. That gives me 2x squared minus x, and then these cancel out. So plus 0, really, which we don't need to write. You can solve this quadratic whatever way you want, but factoring is the quickest way. So that's what I did here. So factored out the GCF of x, then set both factors equal to 0 to solve. So if 2x minus 1 equals 0, that gives me x equals 1/2. So these are x values. So I'm plugging in 0 for x and 1/2 for x. What's the y that goes with it? The y that we were given originally. So when y was 1/2, x could be 0 or x could be 1/2. All right, next, what is the domain? So this is a review from section 3.1. So I look at this, and again, I'm always going to teach this algebraically because it's always going to work. There are no square roots there to consider, but I do have variables in the denominator. So I know that that denominator, which in this case is x plus 4, is not allowed to equal 0. So the value that would make this 0 is -4. So x can't be -4 is one of the ways to write the domain. Or if you wanted to write it in interval notation, so that's what we've been using today, this is how you write anything but -4. I can go from -infinity up to, but not including -4, and then continue from -4 to infinity. Part E, list the x-intercepts, if any, of the graph. So x-intercepts, remember, I plug in 0 for y. So y is really f of x, so I plug in 0, x squared plus 2 over x plus 4. So my first step to simplify this would be to multiply both sides by the denominator. So that just gives me 0 on the left, x squared plus 2 on the right. I know right away by looking at this that these solutions are imaginary. If you don't, then keep going until you realize that they're imaginary. But when I go to square root this, I've got I plus and minus I radical 2. You can't have imaginary x-intercepts. So that's where the if any part comes in. This graph doesn't have any x-intercepts. Last one, list the y-intercept, if there is one, of the graph. Now, I know that a lot of these problems have a lot of work. I do think that what the text is trying to do, and I think it does a pretty good job of it, is it's trying to make sure it gives you the chance to review all the stuff you're supposed to know from high school algebra. So throwing in problems like this is purposeful because it's trying to say, hey, remember when you learned how to solve those rational equations by cross-multiplying? Don't forget that. So that's what it's trying to do. But I'm not a fan of work just for the sake of work. Here, list the y-intercept. I've already done work for that in part B. So I'm just going to write part B, 0, 1/2. Don't do the work over. I already did the work once in this case. All right. So hopefully that helps a little bit and will get you to a good place for your 3-2 practice. And we will answer questions on that tomorrow.